again, we're back to look at some more problems. So this first example says, find the missing angles and sides in the triangle below. It doesn't necessarily matter what we start with. I'm just going to go ahead and start by finding this angle right here. So I'm going to go ahead and call this angle X. I'm going to have to find the other angle, so I'm going to call that angle Y, and then I'm going to deal with the sides in just a little bit. So as we were just talking about, if you know the sides of a triangle, but you don't have enough information on the angles, you can use trig inverse. I can't subtract from 180, I don't know enough, but I can go ahead and use trig inverse. So I'm going to start by looking for X first. So I'm going to go ahead and circle that angle. I'm going to label the sides that I have. So across from X is 7, so that's my opposite. This is my hypotenuse, which would make 15 my adjacent. So if you remember from SOHCAHTOA, sine, cosine, tangent, tangent of theta is opposite over adjacent. And I don't know what it is, so I don't know what theta is, so that's why I'm going to do tangent inverse to find X. I'm going to do tangent inverse. Opposite would be 7 over 15. Now, I could type this whole thing into the calculator if it's in degree mode. I can do that. Or remember that we can use our chart by just converting that to a decimal. So 7 over 15 would be 0.4667. And then I can go look at my trig table. And remember that I'm going to look in the tangent column for what's closest to 0.4667. And I see 0.4663. So closest would be 0.4663. That would be a 25 degrees. So if I go back to that problem, X is about, and I'm rounding, which is why I did that, 25 degrees. That's it. Now, once I know that angle, I can do what we've learned before. If I now know that X is 25 degrees, so I know that this is 25 degrees, and I know that this is 90, and I'm missing one angle from that, all I would need to do is add and subtract from 180. So that's how I'm going to go ahead and find Y. If I have 90 and 25, and I just take those away from 180, so 180 minus 90 is 90, and then I'm going to take away 25, then that leaves me with 65 degrees. So Y is about 65 degrees. And I'm using that squiggle, that approximately, because I rounded the first time, so this would be rounding again. Okay, I found the angles. Now I need to find the sides. So I'm going to go ahead and label this as Z, because I've used X and Y already. Now, I don't need to use trig for this part, because if you think way back, remember, if you know two sides of a triangle, you can find the third one. You don't have to do trig for that. If you know two sides, think for a second. What was your tool if you know two sides? How do you find the missing one? That was just Pythagorean theorem. So that's just going to be a squared plus b squared equals c squared. Remembering that c is always our hypotenuse, or our one that's missing, z, c, same thing. And then a and b. So I'm going to say 15 squared plus 7 squared equals z squared. Okay, and hopefully you know these ones because we've talked about them before. So 15 squared is 225. 7 squared is 49 equals z squared. Remember, whenever you're looking for a hypotenuse, you add. So if I add those together, I'm going to get 274 equals z squared. But that's not the answer. Remember that you have to square root it. And normally from here, if it said simplified radical form, if it said simplify it, then we would have to make our factor tree, but it doesn't necessarily say that, so we can leave it like this. We can just leave it as a square root of 274. Now, if it said round to the nearest tenth, then I would go to the calculator and I would type in the square root of 274, and I would cut that off after one decimal, and that would be 16.6. And either answer would work, or you could simplify it, and that answer would also be correct because it didn't necessarily say. But remember that the default for angles is to the nearest whole number. So let's take a look at another one. It says, can you find the angle at which the tower is leaning? And maybe you know this as the Leaning Tower of Pisa. It should be upright, but it's leaning over, and that's the angle that we want to find. We want to find out how much is it off by. So there's our X. So I do have a right triangle here. There's my right angle. This piece is 16, and this piece right here is 180 feet. So that's across from the box. That 180 is going to be my hypotenuse. And if I look at 16, 16 is opposite of the angle that I'm looking for, so that's my opposite. I don't have my adjacent. Now think for a second. If we're missing an angle, would this be trig or would this be trig inverse? And this would be trig inverse, and I can't subtract from 180 because I don't have enough information. But we already figured out, we know the opposite leg, we know the hypotenuse. So if you remember sine, cosine, tangent, which one uses O and H? And that would be sine, so I'm going to remember that sine of theta is opposite over hypotenuse. So to find that missing angle, I'm going to do sine inverse 16 over 180. Okay, you can go to your chart and figure out what's 16 divided by 180, and that would be 0.08 repeating. So you could look for what's closest to that. I also want you to practice, is your calculator in the right mode? And if it is, then you should be able to go to your calculator and type this in exactly as that is. So second sign key, 16 divided by 180. I'm going to give you a minute to do that. And if you round it to the nearest tenth, or if you see that decimal, it would be 5.099, which would be 5.1 degrees. But remember that we round angles to the nearest whole number, so that degree would be 5 degrees. That would be that angle. And if you looked at it in the calculator, if you did it correctly, it was like 5.09968. But you have to double check. Did you type in sine of inverse? Did you go to mode and change it? And if you did all of that, then you should get the angle that's very close to 5 degrees. Let's take a look at some more word problems. It says that a 16-foot ladder is propped against a building and the angle of elevation measures 55 degrees. How far up the side of the building does the ladder reach? Okay, I know that I'm going to have a right triangle. It talks about a ladder leaning against a building. That ladder is 16 feet long, so that 16 feet would go on the hypotenuse. Okay, angle of elevation. We've talked about this before, like your line of sight is horizontal, and if you're looking up, that angle would go here. It's like your eye is there. It's a very creepy eye. But your line of sight is horizontal. Your vision tends to be horizontal. If you're looking up, that's that 55 degrees. Okay, how far up the side of the building does the ladder reach? And that X would go here. Now, I want you to pause the video and see if you can figure this one out on your own. So hopefully you can figure this one out on your own, but go ahead and pause the video so you can attempt it first. Okay, hopefully you pause the video and you're wrapping up this problem. So if I have an angle and I have a side, it's not a special right triangle. I can't use Pythagorean theorem. We're practicing trig. So you should have circled your angle and then labeled. X was opposite, 16 was the hypotenuse. Opposite and hypotenuse would be sine of 55 equals X over 16. And remember that whenever X is up high, you're going to multiply. But first we need to figure out what is sine of 55. So we're going to go to our chart. We're looking in the sine column for 55.8192. And I'm going to multiply those because remember, whenever X is up high, we multiply. So 16 times 0.8192 gives you 13.1 if you're rounding to the nearest tenth because it's a side. So sides are the nearest tenth. That would be 13.1 feet, which isn't too tall compared to some of the other problems that we've seen. Like 13 feet high, that's not that bad. Okay, this next problem talks about an 8-foot metal guy wire. A guy wire is just like a metal wire that they use to secure things, okay? So an 8-foot metal guy wire is attached to a broken stop sign to secure its position until repairs can be made. Attached to a stake in the ground, the guy wire has an angle of depression of 51 degrees. How far from the foot of the stop sign is the stake to the nearest tenth of a foot? So if you have a stop sign, and a stop sign is an octagon, but you don't have to spend forever drawing this, but an octagon has 8 sides. It looks like that. I'm just going to draw a circle for now. So I have a stop sign. It's coming out of the ground, right? Okay. It talks about the metal guy wire that's attached to it. So that guy wire is essentially going to be up here attached to it, and it's going to make a right triangle because it's attached to a stake at the ground. So there's your stake in the ground right there. So this is your right triangle. It's made from the stop sign, the guy wire, and the ground is what makes your right triangle. Okay, the guy wire is 8 feet. So that is the guy wire, right? There's your hypotenuse. Okay, attached to a stake in the ground. The guy wire has an angle of depression. Now, don't let that angle of depression, angle of elevation, it doesn't matter. It's still going off of our line of sight. So it's always going to be attached to this horizontal piece. So even though it says angle of depression, that is still going to go right here. It's 51 degrees. How far from the foot of the stop sign is the stake? Here's the foot of the stop sign. There's our stake in the ground. This is going to be our X. Okay, I have an angle, I have a side. It's not a special right triangle. This is yet another trig problem. So if we go ahead and circle, this is our hypotenuse. That would be adjacent. Remember, adjacent and hypotenuse use cosine. So cosine of 51 equals X over 8. And whenever X is up high, remember that you're going to multiply, but you're going to go to your trig chart first and find cosine of 51. And there's something really picky about this problem that we need to be careful. Or cosine, sorry. Cosine of 51 is 0.6293. And then I'm going to multiply that by 8. So 0.6293 times 8. And then X would be about, it's 5.0344 is what you end up with in the calculator. But if you go back and you read this question, it says to the nearest 10th of a foot. And if I have 0.03, that would stay at 5.0, but it says nearest 10th, right? So I need to go ahead and say 5.0 feet and put that 0 in there. So just be really careful with rounding. If it talks about having it out to a certain place, make sure you put a 0 there, even if you round, just to show that you know how to round correctly. And that's it for trig part 2. Good luck with your practice.